The button is one of those inventions so good that nobody even knows who invented it.
Who designed the stoplight? These things are so ubiquitous that the person that designed them is forgotten.
But sometimes we forget to ask the simpler questions. We forgot to ask if it could be better. While everything else moves at light speed, phones, software updates, generative AI,
I love AI.
the button has managed to stay the same for over 100 years. Springs, contacts, wear, mispresses, most of us are just used to buttons being buttons at this point. So I asked a simple question. If we design a button today with modern tools and zero assumptions, would it look anything like this? Today, I will try to reinvent the button, and maybe, just maybe, I will create something that will be so ubiquitous one day that the inventor's name will be forgotten.
I think I accidentally just created the clickiest button in the world.
I started by removing the most important component in the button, the spring. Not because it's old, but because it's problematic. Springs hate moisture. Once moisture gets in, corrosion starts, force changes, and the button slowly degrades. Even the air we breathe is filled with moisture, so it's not just liquids. That's why most buttons rely on rubber domes, gaskets, and seals. Not to improve the press, but to protect the spring. Even then, they're just buying time. So I replaced the spring with a magnet array. Let me explain. 3 neodymium magnets arranged horizontally, with their poles aligned perpendicular to the axis of motion. This is the core idea, and yes, I filed a patent for it. Removing the spring also exposed another issue, clickiness. Think about it. Springs aren't actually clicky. They produce a smooth, linear force. That click we're so used to comes from all the extra parts layered on top. Guides, latches, contacts. Each one adds complexity and failure points. With that in mind, I built my first prototype, the MagButton Mark I. A button so clicky that you can't physically half press it, due to the impossibly high force curve from the magnet array. And because there's only magnets inside of the housing, the moving mechanism should be waterproof, or so I thought. There was a fatal flaw with the Mark I design. The magnets were rubbing against each other. Every press caused friction, slowly shaving material away. You can see it in the magnet dust building up on the PLA surface. Once the iron inside is exposed to moist air, it loses its own rust resistance and corrosion takes over. There was a bigger problem too. I hadn't implemented a way to detect the press yet, but I knew exactly what I needed to do. MagButton Mark I proved the fundamentals worked. Now I need to make it better. So I built a second prototype, the MagButton Mark II. The goal this time was specific. Fix the magnet friction problem, add press detection, and prove this mechanism can survive in the real world. First, I simplified the mechanism and kept only what I needed. Instead of 2 rows of 3 magnets, I reduced the system to just 1 row of 2 oversized magnets. The same mag array principle still applies. This meant the Mark II was much cheaper and easier to manufacture, with a grand total of 3 plastic parts plus 2 magnets. The next improvement was durability. Since friction caused corrosion, I had to make some tweaks to the mag array system. Each magnet sits inside of its own pocket, separated by 2 thin layers of plastic. They glide past each other with zero contact, meaning there's essentially no wear on the magnets. And that leads to the biggest advantage of this design. Traditional buttons have to fight moisture with complexity. This button uses simplicity to its advantage. The housing can completely flood with water and the mechanism still works, because there are no electronic or exposed metal parts on the inside, since the magnets are fully sealed in epoxy. The only part that actually needs waterproofing is the threaded mount on the outside of the button, which already exists as an off-the-shelf part in standard industrial designs. Finally, I added a new way to detect the press. Underneath the housing, separated by a solid layer of plastic, is the Hall sensor. As the magnet moves closer, the sensor detects the change in magnetic field and registers the press. All in all, this button has demonstrated that this concept has the potential to disrupt industries that prioritize waterproofing and durability, all while being cheaper to manufacture at scale, thanks to its remarkably simple design. Mark I proved the basic concept. Mark II proved it could fit into the real world. So what's left? I stopped optimizing and I started over. One goal, no constraints, no compromises. build the best button in the world. Introducing the MagButton Mark III. The first thing you'll notice is the shell. Gone is the PLA. The housing is machined from a solid block of aluminum, chamfered edges, lightly anodized surface. The same industrial process Apple uses to make their MacBooks. It doesn't just feel different, it feels polished, like Japanese stationery. Now, the inside. The Mark II has 2 magnets. The Mark III has 12. I redesigned the entire internal system from the ground up. 4 mag arrays, 3 magnets within each mag array. The result is an incredibly stable press, with a force curve tuned to match the average human finger. It feels just right. In addition, I built modular accessories to go with it. First, an upgraded high refresh Hall sensor module. Second, the light module. Snap it onto the main module, and now every press has a visual response. That's the Mark III. And standing here looking at it, I keep coming back to the same thought. You see, nobody paid me to do this. No funding, no lab, no team. Just a pile of failed ideas that slowly became less failed. This is the first time this mechanism has ever existed. So I spent more time than I like to admit ironing out every single quirk before it reached someone's hands. It's not the most ubiquitous button yet, but it's what lets me keep building towards that goal. So if you want to get your hands on this brand new mechanism, it's on Kickstarter, link below. Oh yeah, forgot to mention. The switches in this video, let's just say it's springless.